Hi, let us continue our discussion on data types. We had seen some data types and how to declare variables in our last part. In this part, I had declared a short integer, a long integer, long double, unsigned character, unsigned integer, unsigned short integer, unsigned long integer, and we see the values which have been assigned to them. Notice how I have assigned a value to long double in scientific notation. This E can also be capital E. Notice how I have given -1 and -2 to unsigned variables. I have also declared a hexadecimal variable 0x34 and an octal variable 065. A hexadecimal variable is declared by prefixing a decimal number and characters A through F with 0x. And octal numbers are declared with a leading 0 and digits 1, 0 through 7. I have also declared another double and another float. And also notice I have an expression here, after which I have declared 4 more variables. Note that this kind of declaration is not allowed in C specification prior to C99. C99 allows you to declare a variable at any point of time. Earlier, this was not allowed. I have declared a constant, a register, a volatile, all three being integer. You cannot change the value of a constant. Let's try to change it. I'll give you a compilation error. Let's say I want to make it 9. I save it. So see, you get the error. You cannot change it. And say you do not initialize this variable, then you cannot further assign a value to it. Therefore, you should and must always initialize a constant variable. I have a register. Typically, register variables go in CPU registers, and CPU registers have their fixed width 32 bits. So make sure that your variable size fits into that is within 32 bits. Next we have a volatile integer. Volatile means, this qualifier, what it means is the variable can be changed by your program, but also other entities other than your program can also change this variable. We have next enum. We'll see enum soon, but first let's see how to print these. So we had seen this one in our last part, so let's see this part. I have printed a short int and a long int, unsigned character, unsigned integer, unsigned short, and long. So for long you give L, and for unsigned you give U. For hexadecimal you give small x or capital X. For octal you give small o or capital O. For scientific notation you give small e or capital E. And for long double give capital L and F. The next line computes the size of all the data types which are shown here. The size of character is the size of operator is used to compute. I have used this operator to compute the size of char type, int, long, float, double, long double, void, shortened, and underscore bool. We'll see the output soon enough. Next line says %05d. I'm printing an integer, and this 5 means I want 5 significant digits. and then I say 0, then that means if the number of significant digits is less than 5, then you fill in zeros. In the next line I have percentage 05d space 6d. In this case, if the number of significant digits is less than 6, those will be filled with space. This line, you see, it says that you have to fill up to 10 digits. This is for fractional part and this is for integral part. Next line says plus d. Typically, if you print a positive number, the plus sign will not be printed. To enforce the printing of plus sign, we say plus d. Next statement is a copy, duplicate of this one. Then you say hash x hash o. What it does is, when you print a hexadecimal or octal number, 0x and leading zeros are not printed. So if you want to print those, then you need to give these. And now we see the enum part. An enum is internally an integer, and an enum can comprise of several such symbolic constants which will actually store integers. Let's say this is 0 and this is 1 and this is 2. I have given 3 names in my enum. For once, let's run this program and you see the output. So I implore you to examine the output and match it with the code given in the program. And I want to draw your attention to the last line 0, 1 and 2. So what does it mean is, an enum always starts from 0 and it goes on increasing. There is a very simple rule about enum. If you do not give a value to the elements, first element is 0. Second rule is, if you do not give a value to an element other than the first one, then it will be plus 1 to the previous one. That is, 1 will be plus 1 to 0 and 2 will be plus 1 to 1. Next rule says, if you explicitly assign a value, then it takes that value. So that means if I say this is equal to minus 7, so what will happen to 1 and 2? They will become minus 6 and minus 5. But at the same time, if I say 1 is equal to 78, what will happen to 2? It will become 79. Again, if I say this is equal to minus 49, then these are all explicit. All will have explicit value. I have covered here the most useful printing functions and format specifiers of printf, and in reality you won't need more than this. However, if you want the entire complete reference, then you should look up C99 specification or open group specification document for printf family of functions. You can find that on Google. And I will stop my discussion on data types and variables here, and in the next part we will see operators and operands, how to use operators and operands in C, and till then keep coding. Bye bye.